this reaction I explained that alkyl magnesium bromide or reaction with HCN results in the presence of dry ether results in the formation of imine, which on hydrolysis results in the formation of aldehyde. Here, since we have used HCN, it will always result in the formation of aldehyde, and this R alkyl group can be manipulated by taking corresponding Grignard reagent. So, this point to be noted, the HCN will result only aldehyde. Now, if we take acetonitrile, in that case this will result in the formation of ketone. Ketone will carry, here is the example of acetone, but the ketone if you want to prepare or manipulate where this R group should be different, one of the R group is different, then accordingly Grignard reagent is taken, which will result in the formation of corresponding acetone and corresponding ketone, and accordingly you can manipulate acetonitrile synthesis, you can manipulate synthesis by taking appropriate acetonitrile, appropriate nitrile and corresponding Grignard reagent to give desirable ketone. So, the difference between these two is here we have H only in HCl. So, it will always result in the formation of aldehyde, here it will always result in the formation of corresponding ketone. Next is synthesis of carboxylic acid, which we have already discussed. Here this will result in the formation of corresponding acids. This acid will have one carbon atom, additional one carbon atom from the carbon dioxide. Here the attack of this nucleophilic carbon will take place to the carbon or the in presence of dry ether, and on workup of the reaction it will result in the acetic acid. If you want to make the higher acid, you have to take one carbon less of the desirable acid as a part of Grignard reagent. Say we want to synthesize butanoic acid. So, the Grignard reagent will be your propyl magnesium iodide or propyl magnesium halide. So, this will result in the end product will have the 4 carbon system, that is butanoic acid. Similarly, if we take aryl magnesium iodide, it will result in the formation of aryl carboxylic acid. In case of phenyl, it will result in the formation of benzoic acid. So, there is, remember this thing, there is always increase of one carbon atom from the Grignard reagent. Now, synthesis of higher alkynes. Now, higher alkynes can easily be synthesized by using Grignard reagent. As we know, the acetylenes, the terminal acetylenes or the acetylenes, the terminal alkynes have their H is acidic in nature, and on treatment with Grignard reagent, this H is easily removed and result in the formation of acetylenic Grignard reagent, and this at the Grignard reagent part, this alkyl group is removed as corresponding alkane, here it is CH4, and this acetylenic Grignard reagent which is formed, that is ethynyl magnesium iodide which is formed, will result in the formation of propyne. Here this carbon will attack, and then MgI will be removed and we will have propyne as the product, and similarly this H is active. So, you can extend the chain at this end in a similar way. Next is synthesis of higher analogues of ethers and alkanes. Grignard reagent reacts with the haloalkanes to form carbon-carbon bond. In similar way, it reacts with substituted haloalkanes such as halogenated ether, halogenated alkenes to form higher analogues of ether and alkenes. In this case, say RMGX is treated with the chloroethers in presence of THF as a solvent or any other suitable ether as a solvent, it results in the formation of corresponding ether. Here the ether carbon chain is extended to that end where the chlorine is attached. So, it is behaving like this portion is behaving like a haloalkane this part. So, it results in the formation of the extended carbon chain in ether. So, here the eliminated part will be MgX2. So, and the next is if you take allylic carbon, the allylic double bond is there, even then this gives the excellent yield when it is treated with the Grignard reagent. Here in this case we will get the corresponding alkenes with the higher number of carbon atoms. The number of carbon atoms will be added in the form of R as we take in the Grignard reagent. So, this is synthetic use of Grignard reagent for the preparation of alkenes and extending the chain in case of ethers. Now, this reaction mechanism is basically this again the positive and negative charges are there, it is easily replaced and it results in the formation of corresponding extended ether. So, if you have this is a specific example and it has the methyl magnesium iodide, iodo ether is there. So, it will result in the formation of corresponding this is ethoxy ethane as a final product. So, Grignard reagent on reaction with cyanogen chloride results in the formation of alkane nitrile. This method is used to the preparation of tertiary alkane nitrile. Now, this reaction provides an excellent method for the preparation of nitriles, like we have ethyl magnesium iodide treatment with the cyanogen chloride, it results in the formation of corresponding nitrile. Here the propane nitrile is there and we get corresponding magnesium iodochloro magnesium. Now, in this case it provides the excellent route for the preparation of corresponding nitrile. These type of nitrile can be synthetically used as explained earlier, where the nitrile results in the formation of ketones. One can really use the synthetic plan the synthetic strategy by using this reaction followed by the earlier reaction which explained earlier for the synthesis of ketones. Similarly, if we have tertiary magnesium iodide which results in on reaction with cyanogen chloride results in the formation of tertiary cyano product, and then next is reaction of Grignard reagent with isonitrile results in the formation of aldehydes and amines. This is a typical reaction where the isonitrile provides this complex, imine complex is provided, and this on hydrolysis results in the formation of a molecule of aldehyde and then molecule of an amine. So, this basically this aldehyde part is a result of this carbon in isonitrile, this constitutes this an aldehyde portion and this results in the formation of amine. So, number of carbon attached is R1 is there. So, R1 will result in the formation of amine and this chain R which will go to that carbon of the isonitrile this carbon and it will result in the formation of aldehyde. Now, synthesis of amines. Now, this again the reaction with methane isonitriles. In this case, ethyl magnesium iodide on reaction with methane isonitrile, it results in the formation of corresponding amine, and this on subject to hydrolysis will result in the formation of methylamine and propanol. Now, in this case, as explained earlier, it is a specific example. In this case, CH3N, this will result in the formation of amine because of the hydrolysis of this part, and other two carbon atom system where the one carbon is added from the methane isonitrile to the Grignard reagent, which on hydrolysis will result in the formation of corresponding aldehyde. In this case, this is the propanol. Now, synthesis of thiol and thioethers. Now, this provides Grignard reagent provides an excellent route for the synthesis of thiols and thioethers. Grignard reagent on reaction with sulfur compounds on sulfur, it results in the ethyl thiomagnesium iodide, which on reaction with the methyl iodide results in the formation of thioether with an excellent yield, and on hydrolysis this ethyl thiomagnesium iodide results in the formation of thiols, and this also provides an excellent method for the preparation of corresponding thiols. Now, with reaction with carbon disulfide and sulfur dioxide, formation of dithiocarboxylic acid, dithioether and sulfanic acids. Now, RMGX or Grignard reagent on reaction with carbon disulfide in presence of THF or any other suitable ether under anhydrous condition, this carbon attacks this is a carbon attracts to this carbon which has a positive charge, and then it results in the formation of corresponding Grignard reagent, where the which on hydrolysis results in the formation of dithiocarbanoxylic acid, and then on reaction with further haloalkane it results in the formation of dithioether. So, this provides an excellent route for the synthesis of dithiocarbanoxylic acid, and on reaction with haloalkane it results in the formation of corresponding dithioesters, and on reaction with sulfur dioxide and in presence of ether, this results in the formation of sulfenic acid, and it is an excellent route which results in the formation of the corresponding sulfenic acids. Next is synthesis of organometallic compound. Reaction of Grignard reagent with metal halides results in the formation of other organometallic compounds, where we have this tin tetrachloride which forms the organotin, and on reaction with the lead chloride it results in the formation of TEL, which is a very popular compound in the petroleum industry to be added. This is known as TEL, tetraethyl lead, and then with cadmium chloride it results in the formation of diethyl cadmium. All these are the industrial products, and Grignard reagent provides the excellent route for the preparation of organometallic compounds via this route. Now, synthesis of organometallic compound, that is transmetallation of Grignard reagent. This reaction takes place with mercury compound. Now, Grignard reagent, 2 molecules of Grignard reagent 2R-MgI on reaction with mercury chloride, it results in the formation of organomercury compound, and this is an excellent route for the preparation of organomercury compound. Now, these type of organomercury compound normally find the use in industry and as a powerful bactericide, etc., but their use is these are not used because of the high toxicity, but this gives the excellent route for the synthesis of organomercury compounds. Now, another reaction is very important, preparation of organosilicon compounds. Here the tetrachlorosilane on reaction tetrachlorosilicate on reaction with tetrachlorosilane on reaction with the 2 molecules of Grignard reagent results in the formation of dichloroethylsilane. Now, this is again an industrial product. Silicons are silicon compounds are excellent products for the purpose of different industrial use. So, this transmetallation route provides an excellent route for the synthesis of these type of compounds. Now, in the next slide, limitation of Grignard reagent. It is very important to note the limitation of Grignard reagent. The organic halide used for the preparation of Grignard reagent should be selected carefully, because Grignard reagent cannot be prepared from the organic halides having an acid or active hydrogen containing functional group such as OH, thiol, amine, carboxylic acid and sulfuric acid group. This we have already studied in one of the slides at the beginning. In the preparation of Grignard reagent from the such functional group containing halides, the Grignard reagent form decomposes immediately under the reaction conditions only. So, if you are synthesizing any functional group and as a substituent halogen is present, so Grignard reagent will react with that group also, and it will decompose within the reaction condition, or it will create the mess in the reaction condition. Now, the Grignard reagent cannot be prepared from the organic compound containing groups such as carbonyl, epoxy ester, nitriles, acyl chloride, as Grignard reagent is reactive towards these functional groups. So, that states that if you want to prepare the Grignard reagent which is already having the carbonyl group or epoxy ester or nitriles or any other group like acyl chloride, Grignard reagent cannot be prepared, because Grignard reagent reacts with this group. So, it cannot be prepared. So, that is the biggest limitation of the Grignard reagent. So, here is one of the strategy which is here we are now discussing, that is strategy in the Grignard reagents. Here the one of the product is, that is estophenone, sorry, it is estophenone, the para-bromestophenone is there. If we have to react with the Grignard reagent, it is not possible, reason being, and if you want this product, it has to be from the Grignard reagent, a secondary alcohol. But if we will not take the precaution, that Grignard reagent formed will react with the ketonic part as well, and the reaction will not give the desirable product, because the in reaction medium Grignard reagent will react with the ketonic part also. So, this requires the protection of carbonyl group to get the desirable product. So, the synthetic strategy is involved, that in the starting material where the ethene 1,2-diol, which is a protecting group for the carbonyl compound in the presence of acid, it protects the carbonyl compound, that is acetone in this ketonic group in this case, and epoxide, this cycloketal ring is formed. Now, this is protected. So, we can proceed for the formation of Grignard reagent, where the magnesium will be inserted in between Br and Cc bond, and it will result in the formation of Grignard reagent. Now, on reaction with the aldehyde, depending on the requirement of the desirable product, end product. So, when this is reacted, it will result in the formation of secondary alcohol, at this end para to protected carbonyl group, and on workup of the reaction, and with deprotection will take place, and we will get the desirable product. So, in this slide we have seen that directly we cannot prepare this product, because the aldehyde group which will react with this Grignard reagent which is formed, if had it not been protected, this Grignard reagent once it is formed, it will within reaction condition, it would have been reacted with the carbonyl compound of the same molecule, and would have created the different product, and reaction will be messed up, would have been messed up badly. So, this provides the excellent route strategy for preparing the using Grignard reagent while protecting the one of the product which is already very reactive towards the Grignard reagent. So, now we will proceed somewhat, we will revise some of the important reaction and conditions quickly. So, this will recapitulating everything quickly, and especially in the starting. Now we have already seen in many reaction which explains that why dry ether has to be used, because dry ether, if it is not used, water will react with Grignard reagent, it will result in the formation of undesirable product, that it will be converted into RH, that is corresponding alkane. This we have already studied, and the reactivity order is Ri, that is idoalkanes will react much faster with as compared to bromoalkane and as compared to chloroalkane. So, this we have to keep this in mind, and that dry ether is the important reaction condition, and that we have seen here in this reaction. Yeah, in this reaction, where all the reactive active hydrogen containing compounds which are there, they all result in the formation of the same alkane. So, if we use water, so the net result will be alkane, not the desirable Grignard reagent, because that will decompose and result in the formation of alkane. And similarly, deuterated compounds can be prepared from the Grignard reagent, otherwise very difficult to prepare deuterated compound in the organic chemistry. So, if we take this bromo and prepare the treat it with the magnesium, we will get the corresponding Grignard reagent, or then and followed by treatment with the D2O, alkane will be found, but it will be a deuterated one. So, exclusively if we take one alkane with though no isomeric structure is there, we will get just one type of deuterated alkane. So, this provides the excellent route for the preparation of deuterated product in the organic chemistry if we want. And similarly, at the quick glance, the reaction with carbonyl compound, depending on the which carbonyl compound we have taken, whether the aldehyde or ketone, corresponding product will be secondary alcohol or primary alcohols will be found. But remember, formaldehyde will result only in the formation of primary alcohol, but other aldehydes will result in the formation of secondary alcohol. And similarly, the benzaldehyde will result in the form of aromatic alcohol, and the ketones, no matter which ketone is there, it will result in the formation of tertiary alcohol. So, this main precaution is that it has to be worked up in the presence of ammonium chloride, otherwise there will be beta elimination, the end product will be corresponding alkene. This beta elimination takes place as per the states of elimination depending on the starting material. So, the tertiary alcohol will be formed if we take benzophenone, and this is the reaction condition, different set of reaction. We can take different Grignard reagent, a different type of ketone depending on your synthetic strategy. In this particular molecule, we can synthesize this molecule by 3 routes: by designing Grignard reagent, followed by corresponding manipulating the corresponding aromatic ketone, and or simply acetone part from the acetone plus the Grignard reagent part from the aromatic system. So, these are the quick recap, and the epoxide will result in the formation addition of 2 carbon and will result in the formation of primary alcohols, and substituted epoxide will result in the monosubstituted epoxide will result in the formation of secondary alcohol, and this disubstituted will result in the formation of tertiary alcohol. And the point to be remembered, important part, the oxocyclobutane, which gives an excellent result, and it provides a 3 carbon atom system. So, at one go either you prepare pentanol, or if you want to extend it further. So, you can extend the Grignard reagent to get the desirable product. So, here the combination of 3 carbon plus how much carbon you want, that will come from the Grignard reagent, and that will end up with the final product. Suppose you want 4 carbon atom system here of the Grignard reagent, that is butyl magnesium bromide plus 3 carbon. So, 7 heptane 1-ol will be the end product. So, similarly, secondary alcohol from ethyl format will result in the formation of secondary alcohol. The important point here is that this will consume 2 molecules of Grignard reagent, and similarly this with ethyl format it will also consume 2 molecules of Grignard reagent. So, the end product is not the ketone, but instead it will result in the formation of tertiary alcohol, and with nitrile it is the excellent route for the preparation of corresponding aldehyde. At the end, we can summarize this by these are the limitations of the reaction where we can use this, and these are the synthetic strategy where we have used the protecting group to explain the how to mask one of the group which is highly reactive towards the Grignard reagent. And now, these are the key references of the books which are there. The first book is Mehta, Bhupinder and Manju Mehta, and I am the author of that book. Thank you very much.